Welcome to anyone watching, it's Craig at mysimpit.co.uk and welcome to part 14 of the front dash build. In this video we'll be looking at the landing gear panel, and in producing that we'll be using a number of standard electrical parts, 3D printed items and some real aircraft components too. We'll then take the completed panel and integrate it into the front dash frame and then bring that online. Let's buckle up. So I found this a really interesting panel to make, more than anything because it's such a mix of different types of components and inputs and outputs. So in this video, the first thing we'll have a look at is a scale print of the design, just to check that the components will definitely fit into that. And that'll lead nicely into a look at the landing gear handle, which I've sourced from a real Tornado. Then we'll look at the landing gear position lights that will effectively be a 3D printed unit holding a number of LEDs. The flat position indicator will use just a cheap servo motor, and again that will be suspended behind the panel with some 3D printed parts. The anti-skid switch, I've managed to source a Honeywell magnetically held toggle, so it's the first time I've used one of these in my Simpit, so really looking forward to putting that in place. And then finally the landing light switch, which will be a standard toggle, but I'll design and 3D print a cap that will attach to that. I always find that a scale print of the CAD CAM design is always really helpful, just to be sure that all the components will fit and it's all going to work. So I do this for all of the other components that I have and think through any of the ones I have yet to design, and then that leads me to the point where I can produce that fascia. We can now start looking more closely at each of the 5 key parts of this panel. I managed to source 2 landing gear levers that were from Tornadoes. We can see one of them in front of us now. This was the one of the 2 that was in the much better condition, and I took some time to just be clear on how I can energise the lamps and how I can energise the core for the downlock override, and also, given all of the pins on the back, how can I interface with those for it to be able to recognise the position of the lever. The handle is really straightforward to take apart and detach from the actual lever. It's just broken into 2 parts and all attached back together with 1 screw. Although there is an option of putting LEDs inside the handle, I was quite keen to try and use the actual original lamps, and here we can see that one of the 2 in this still works. The second lever I got was bought in the knowledge that there are a few issues with it, and one of them being, and this is the one we can see on the right, is damage and that the mechanism won't move, it's jammed. So the bulb we see here on the left has been taken from the one on the right to replace this one that was broken. In the future I do plan to look more closely at the broken lever and see what I can do to potentially repair that unit, but I think at this point to take parts from that to get the other one working fully works well for me, so quite pleased I've got 2 working lamps in that now that are both originals. I ran some tests to start thinking through how this simulator will control the solenoid for the downlock override button, so that allows free movement of the lever upwards when you want to retract the landing gear. So all looks good and working as it should be. The second main key part was to look at the landing gear position lights, and here are a number of 3D printed parts. I've designed them in Fusion 360 and then printed them ready for the LEDs to be housed within. For the windows of the indicator lights, I've used a frosted acrylic as opposed to an opal, because when they're not backlit I don't want them to be quite as prominent. It sure does make a difference to do some work on these post-print to use a smoothing compound. If I flip this over we can see what the surface may otherwise look like, but by using one of the compounds and then painting it gives it a much better finish. I then integrate it into the panel, and I've put it and held it in place with some hex socket screws as a change to the typical crosshead that I use. I think it gives it a bit of a better look. It's time to start running some tests to get it talking to the sim, and also in terms of the lighting, to be happy that the spread of light's even. So I've used 2 LEDs per each of the 3 windows, and I've added on a little board that will allow each of the 3 sets of 2 LEDs to each be powered in parallel. In this test we can see that the indicator lights reflect what's happening within the simulation. I think using 2 LEDs per window was definitely the right choice. Back when I did my prototype, my caution light panel, I did 1 per window, and from that I remember at the time thinking that was just not enough. So sticking to 2 means you've got an even spread of light. The third key part that we'll look at now is the flap position indicator. First we have a 3D print of the bezel that will sit on the top of the fascia. Then we have a holder that will suspend at the back the markings of the flap position. And we then have a final print which is designed to hold the servo and to also suspend that in place behind the panel. It did take some time to design these, to print them and to test them and then refine and reprint, but the good thing is I get to have that design ready to utilise for other servos and other parts of the Simpit. And this is the main part of the flap position indicator assembled as one unit, designed to allow the transmission of light so we can effectively illuminate the actual gauge. I spent a good bit of time designing the pointer that would just slot onto the top of the servo motor. The main part was to get the shaft the right size and the right spacing and size of teeth within it. With that part right, so it can fit onto that type of servo, it's then easy to alter the height or the size or the length of the pointer in any way that is needed. So a quick couple of coats of white paint just to get the pointer all finished, and we start to get something that's more usable. So let's take a look at that now it's built into the panel. When I previously did the engine monitoring instruments, I didn't put bezels into that panel, and this was the first one I have, and I think it does make a difference, and if I was to redo the EMI panel, I think I definitely would have that in place. I did think about using a stepper motor for this, but for such a small range of motion that you have for the flaps indicator, the servos work just fine. Right, let's see how this talks to the sim. Looks good to go. The fourth key part was the anti-skid switch, and for this I've sourced a Honeywell magnetically held toggle, something that I've been really keen to get into the Simpit for some time. So what we can see there is a release of the toggle when the switch is no longer energised. So again, it's moved into position and held, and then released. The toggle is momentary when it's not energised, but once powered and energised, it becomes a fixed position switch. I've been running a series of tests to understand the current draw of this component, and also to see how I can control it from the sim from an Arduino pin output of high fed through a MOSFET. And in this case it's related to the electrical control panel. So when the battery power's on, it recognises it as high and it's energised. If you turn off the battery power, it cuts the power to it. And let's just try that again for good measure. Over to the A10's electrical panel, and let's cut the battery power. Not the means by which it's powered on or off within the real A10, but just to fulfill this test. And now we get to the point where all of the key components are in place, and we can start to build up the rear layers of this panel. And I use some now, I print some which are to act as spacers to support other components that are needed. I have found it really helpful to use a 3D printer, and from a time point of view it took so much longer before to go and make things by hand that now you can just design them and within a few hours they're all printed up. We can start to suspend in place now some of the components that lie further back at the rear of the panel. What we have here is a control board which is effectively 4 MOSFETs in one. For ease of testing previously I used individual MOSFETs, but at this point I can feed everything through this one board that contains the 4. And we can start testing and bringing various parts of this panel online, like the backlighting that we can see now. The 5th key part was the landing light switch, and the image here is what I wanted to base my design on and make it look as close to as I could. So I ran a series of design and test prints to see which I could find that would fit and look the best. I did look at metal ball bearings, but ultimately I actually had some small plastic pellets from an airsoft rifle which actually were the perfect size and were more in keeping with the image that we looked at than the ball bearings. Just like the indicator lights and the bezel for the flaps indicator, I did some work on this post print just to give it a smooth surface to then paint. I used a number of different paints just to find the one that would give it the best look. I tried several in a silver metal, and the one on the left we can see I tried in a military grey. The metal look was definitely the most in keeping with the initial image and design I wanted to base mine on. And what we're left with at this point is a small number of finished toggle caps, and it's just a question of picking the one that we're going to use. And this one will do nicely. A few finishing touches. I wanted to be able to remove the landing gear lever without having to dismantle the handle, and I've left that opening to the side of the panel, which obviously I want to place something over that. I did a couple of prints for that, and we can see the one on the right came out that bit better. So we'll go ahead and put that in place. And we're at the point now where we've got the completed panel, which we'll take a close look at now before we go ahead and install that into the front dash frame. The cap for the landing light switch is held in place with some glue, but the one thing to bear in mind is that the actuator itself doesn't rotate, or you'll still have some movement. This panel is interfaced into the computer via a split of DCS BIOS and a keyboard encoder. The rear has 3 RJ45 sockets and 2 power inputs for 12 volt supplies, one that controls the MOSFETs, the other controls the backlighting. And at the top there you can see a small distribution board I've made, and that is for the wiring for DCS BIOS, to weave its way through to the different components. The wiring for the encoder is always somewhat simpler because it relates to inputs only. So we can go ahead and install this into the front dash frame now. For this and other panels that I'll be installing into the front dash, they really need a hub for DCS BIOS that can sit within this unit. So I'll go ahead and start designing a small enclosure that can do that. So my idea being, as other panels are installed into the front dash frame, this hub is ready and waiting just for them to be connected to, and that's already in place talking to the sim. To allow a good number of options and flexibility, it's designed to accommodate a large number of keystone jacks. It has in place breakout boards for the ground and 5V pins of the Arduino. At the rear I've put a port to accept a external 5V supply with its own distribution rails, and the idea being that other components that need to be powered at 5V can be done so separate to the Arduino itself. And we can see that in place now. And we'll just come around the side and have a bit of a closer look at that. But it's there now to control this panel as we bring it online, but also ready and waiting for other panels that will be installed in the future. It's time to bring this panel online and put it through some initial tests. Check it's all working as it should. Middle of the screen we have an overall view of the Simpit. Right of the screen a close-up of the landing gear panel, and left of the screen a brief title showing the particular part of the panel we're testing. And let's take a look at these from an external view. We'll take a look now at the Antiskid Switch and the landing lights. We'll just take a final and further look at the Antiskid Switch. Now with this one, I've tied the control of it just at this point to the electrical control panel. Let's turn battery power off. So if battery power's on, the switch is energized. If it's off, it's de-energized. And when this switch isn't powered, it's effectively momentary. Otherwise, it'll hold its position. So in initial test flights, the panels work well. Definitely took a fair bit of time to build this one. Quite a mix of components in it, and time to source, some time to research and learn how to get the best from them, and the time for some of the 3D print designs and then refinements needed to them. But a nice addition to the front dash. And as we finish the video here, just take a brief look at the Simpit so far and the front dash as part of that. After using a magnetically held toggle in the landing gear panel, I'm really tempted at some point to do an upgrade to the SAS panel so I can have the 4 existing basic toggles in there upgraded, but that may be some way into the future. With the armament and landing gear panels installed into the front dash, it's now enabled me to put the MFCDs in place. At this point I'd say that the front dash is about 1/3 complete, and there's still a lot of work to do on it. so I can see this rolling on for quite a number of months to get this part of the project near completion. I'm now going to research into OLEDs and vacuum filled displays for the front dash, and I look forward to sharing that in the future. Thanks for watching.